pages is nothing that you need to know. Okay? So the first 2 pages, the reason why I put it there, you can read through it, but what I want you to know is that at the beginning, right, 5 years before Christ, they thought, okay, we must all be made out of particles. And then they said, okay, these particles must be like a ball. And then they said, okay, but in this ball there must be different things. And then they said, okay, but there must be electrons and protons. And then later on they discovered neutrons. And then they discovered orbitals and how many electrons in each orbital. And then they discovered that, wait a minute, they don't just move in orbitals, they move in waves like this as well. And. So the latest discovery was 1932. Okay? But there might be something that they've missed. Maybe you will become a scientist and you will discover something new regarding the atom and the nucleus, electrons, and. Okay, so just so that you know, we didn't always know an atom has electrons and protons and neutrons. It was actually recently discovered. In the last 100 years, 150 years, they discovered that. Okay, so there might be more things to discover, so you must always be curious and always ask a lot of questions. Okay. Then we're going to get to what we must know now. So we are looking at the atomic structure as we know it today. Today we know that atoms consist of protons and neutrons. And they are together in the nucleus, the small nucleus. And they are surrounded by electrons spinning around them in orbitals. Okay. So inside the nucleus, we have protons and neutrons, and around them we have electrons spinning. You did this in grade 8, yes? No? Okay, I'll show you a video in a moment. All right, then the protons and neutrons together are called nucleons. Nucleons. So together, like you are boy learners and girl learners, and we call you students or learners or whatever. Same thing, so we have neutrons and protons, and together we call them nucleons. Alright, and then in a neutral atom, what is a neutral atom? What does that mean? It's not charged, something is the same. Yes? It has the same number of protons as electrons. Not no protons and no electrons, no, just the same number. Okay. So, if for instance we have, let's take an easy one, let's take carbon. Carbon has how many protons on the periodic table? 6. It has 6 protons. So, how many electrons does it have? 6 electrons as well. So, you see the number of protons on the periodic table. That's 6 next to carbon, tells you the number of protons. And then if it is neutral, then it has 6 electrons as well. Okay, now sometimes carbon becomes carbon 4+. What does that mean? It lost or gained electrons. Is electrons positive or negative? Negative. So if it becomes positive, then it means it lost electrons. It lost the negative thing. Can it gain protons? No, then it's an atomic bomb. It can't. So here, it still has 6 protons, but now it only has 2 electrons. So 6 positive things, 2 negative things gives you 4 positive. Okay. But we're going to do that a million times in this chapter. So in the nucleus, we have protons and neutrons. And their relative mass. It's very difficult to measure their mass, but we take their mass to be around about 1. Today, we're going to speak about 1 unit. So U with like a longer line in the front, 1 unit. Later on, we're going to discuss what this unit actually is. Then a proton is positive and a neutron is neutral, no charge. Okay, so proton positive, neutron no charge. And then together the mass of an electron, an atom, is the number of protons plus the number of neutrons. That together gives you the mass of an atom. Okay, and the protons gives you the type of atom you are working with. So if you have 6 protons, you'll always have carbon. If you have 17 protons, you'll always have chlorine. So the number of protons gives you what type of atom you're working with. And together the protons and the neutrons gives you the mass of the atom. Then in the orbitals around the nucleus, we have the electrons. Now it says there the mass of the electrons is neglectable. What does that mean? Neglectable. The mass is neglectable. If I say, ooh, I can see that that child is neglected at home. Ignored, not looked after. Okay? As if it's not there. So if we say the electron's mass is neglectable, then it means it's so small we don't even consider it. It's nothing. Okay, so it is way too small to even say that it has an effect. It must have a mass, otherwise it doesn't exist, but it's way too small to even think of it as something. Then the charge of an electron is negative, -1. And the function of an electron is to give its volume and its chemical reactivity. Okay, you remember, I can't remember who sat there where Orna usually sits, and I asked, what did you say about it? I asked someone to put up their pencil. Do you remember that? And I said, if we take away all of the electrons, it will shrink. Who sat there? Was it really him? All right, so you remember when I said that, if we have a pen, they're in the middle, and the pen was where the dot of the tip of the pen was where the protons and neutrons were, then the electrons would be all the way to the walls. They are so far apart, away from each other. And if we take away all of the electrons, then let's say it was this table, then that table would shrink to the size of the tip of your pen, but it will still have the same mass. Okay, so all of the mass is in the nucleus, and all of the volume, the size, is in the orbitals. Okay, so quickly look at the helium atom. Helium, if you look on the periodic table, is in which group, Sibabatso? Group 18, and what's group 18's name again? It is the noble gases. Okay. Then, Zora, how many protons does helium have?
2.
And Courtney, how many electrons will it have?
2.
And then, Tsepo, difficult question for you. How many neutrons will it have? You're going to take a guess, and you're going to guess correctly. Oh, yeah. Incorrectly. 2. Okay, but why 2? It's not just 2, 2, 2 always. Did I give you a periodic table again? Yes. Okay, I want you to go to the periodic table later on in this chapter. Okay, on your periodic table, you see that the number that is given there at the bottom is the mass. Okay, so if you look at neon, there not neon, helium. There at the top is 2, that is the number of protons. It's the atomic number, the number of protons. There at the bottom is the mass, the 4. Okay, so the mass of helium is 2. Now, if we go back here, if we see that the mass is 4, and we also know that the mass consists of the number of protons plus the number of neutrons, how will we get the number of neutrons on its own? Well, if the mass is 4, how many protons are there in helium? 2. So how many neutrons will we have? 2. 4 minus 2 gives you 2. So we'll have 2 neutrons. Okay, let's quickly take another one just to practice. Let's take lithium. Lithium. What's the mass of lithium? What? 7. And how many protons does lithium have? 3. So how many neutrons will it have? 4. See, how can you see on the board?
Yes.
Why are you squinting your eyes? Can you see? Really?
Yes.
What did I write here? Okay. Sharp. All right. So, do you see how we calculate this? Okay, because you're going to calculate that a lot. So, if we look at helium there, then we saw that it has 2 protons. So, protons we find where? In the nucleus, in the center. The nucleus is the center. We have 2 protons. In the center, we also have 2 neutrons. And in the orbitals around it, we have 2 electrons. Now, why do I draw the electrons so far apart from each other? What do negative and negative do? They repel each other. And these electrons, they move around like this over and over and over and over again. Okay, so they will repel each other. But why do this not repel each other? There is a force that keeps them together. Yes, they want to repel, but the force that keeps them together is that's the most amazing part. It's bigger than the force that they repel. But as soon as you add too many protons, then they will start to repel each other and it will form an atomic bomb. And that is why those elements there at the bottom have that radiation sign, because they automatically split up. All right. So in the nucleus, that is the nucleus there. That there is the nucleus. In the nucleus, you find the nucleons, and that is the protons and the neutrons. There, the protons and the neutrons. Okay, then we have the atomic nucleus. Atomic nucleus, that is just what the atom consists of, the nucleons. Now, we are going to have like a symbol to represent all elements. Okay, so the symbol we represent elements is an E. You will see nowhere on the product table you will find a capital E, so that E represents all elements, a E. And then we want to write down its atomic number and its atomic mass for each element, like it is on the periodic table. If you look at gold there, you see there at the top, you have its number of protons or its atomic number. And there at the bottom, you have its mass. How do we get the mass again? The mass is the protons plus the neutrons. Okay, so we want to take this and we write it just a bit differently when we are not on the periodic table. Okay, so that E represents the element. The Z there at the bottom, that Z represents the atomic number. Now here is a definition that you need to know. What is an atomic number? It gives the number of protons in each atom of that element and its position on the periodic table. That is what an atomic number does. It gives the number of protons that we have and where you will find it on the periodic table. Because if I tell you, please find element 16, you will all now start to know more or less where to look, right? You'll say 1, 2, 3, 4, 16 there. Okay, so that number tells you more or less where it sits on the periodic table. Then we have the mass number. Now that symbol for that is a capital A. And the definition for the mass number is the total number of protons and neutrons in each atom of an element. Okay, so I think this is the third or fourth time I've said this. So the atomic number gives you the number of protons, atomic number, and the mass number gives us the number of protons and neutrons. Okay, so if I ask you what is the atomic number of aluminium, what are you going to tell me? It's 13. Alright, so if we look at, let's say, aluminium, and you tell me the atomic number is, what did you say? 13. We will write a 13 there at the bottom. So I'm mimicking, I'm copying this thing. So the element is aluminium, so write down aluminium. The atomic number, Z, is 13, so write down 13. What is the mass for aluminium? Can you see there, Kamu? For aluminium? Number 13. Look for number 13. It is 27. Then we write, dank je, Rory. Then we write a 27 there at the top. You see? How many neutrons will aluminium have? Yes? How did you get to 14? 14. Do you know what you wrote down when you wrote down 14? 14 neutrons, right? How do the Americans pronounce aluminium? Aluminum. Alright, let's look at another one. Let's say, what is the atomic number of zinc? Okay, atomic number of zinc. So we go zinc. The atomic number is 30. So we write a 30 at the bottom. And what is the mass of zinc? 65. So how many neutrons will it have? 30? Huh? Look here. A 30 on the dot. 35. That is the electronegativity. We're going to get to that. Alright. So here I just say again, when you subtract the two numbers from each other, you get the number of neutrons. Okay. So let's look at this exercise at the bottom. We have helium, sodium, and uranium. We must write down the symbol for it. Then the number of protons. Remember, hashtag means number of. Number. Yeah. Alright, number of protons, neutrons, the charge of the nucleus, and then the number of electrons. Okay. Helium. Where am I with our questions? Ntando, helium. He. And what is the number that we write here? The Z. What is that number for helium? 10. Why is it 2? Yes, because you just listen to other people. That is the atomic number and the total number of protons. And Kutlano, what is the A for helium? The mass. Oh, you open on the periodic table. Do you have a periodic table in those notes? Are you going to open your... Where's your flip file? He's always like that. Helium, yes. 2 is the number of protons. I want the mass. So what I write there at the top? It's 4. So can you see from your periodic table to mine, the thing, or not mine, to what we must write down here, is on our periodic table it says 2, 4. Yes? So you basically just swap them around. Alright, so the number of protons is 2. How many neutrons, Rita Bile? How did you get to 2?
I said 4 minus 2.
Yes. Then what is the nuclear charge, Sia? What do we find in the nucleus? The what and the what? Protons and neutrons. Okay, so in this nucleus, we have 2 protons and 2 neutrons. What is the charge? Do the neutrons have a charge? No, they have no charge. So the charge is +2. For the 2 protons, it gives the charge. And then, Nyakano, how many electrons? 2. Wait. Okay. Then they tell us there we have sodium. Rory? Symbol for sodium? Say again? Na. Then, Bukamuso, what number are we going to write down at the bottom? And at the top, I hope? Sodium. Na. $23. All right. So how many protons will it have, Floni? Yes, 11. And how many neutrons, Kamu? How did you get to 12? That gives you 12. What is the nucleus charge, Relo? Plus? Plus? Do the neutrons have a charge? No. So what is it? In the nucleus, we have the protons and we have the neutrons. But the neutrons doesn't have any charge. So then it's 11. Alright, and then they tell you there the number of electrons is 11. Next one, uranium. Uranium. Sivavatso. It's a U. And then the number at the bottom, Zora?
92.
And at the top, Courtney?
238.
Okay, so how many protons do we have, Sebo? 6. Who did you listen to? No, 32. What did you say? 92, yes. Ntando, what is the nucleus charge?
Also 92.
Positive 92. Okay, and then how many electrons, Kutlano? How many electrons? 92. All right. Then, in life, we get twins, right? Do you have twins in your grade? No, in your grade, twins. Do you know any twins in school? See them? I think in grade 9 this year. There's lots of twins in grade 9. So. Alright, but yes, the English one is Carabello and Carabu. Yes. So, do they look exactly the same?
No.
Yes.
Okay, so some people say yes, some say no. If you don't know them, you just see them there, then you're like, yup, they look. When they walk in grade 8, I was like, there's no way I'll ever know who's who. But as soon as you get to know them, you see there's actually a clear difference between the two. They are two different human beings. Now, we get the same for elements. Okay? Some elements have twins, or sometimes they're triplets or quadruplets. Okay? So some elements aren't just one of the same. There's two, let's say two hydrogens. They look the same, but there's something that's different with them. Okay? And we get triplets and quadruplets as well. And we call them isotopes. Isotopes, these twins. Okay, so the definition there says isotopes are atoms of the same element. So hydrogen, hydrogen, chlorine, chlorine. But what's different is they have a different number of neutrons. And thus they have a different mass. Okay, so same element, same number of protons, everything is just the number of neutrons that are different. Okay, so just for extra information, isotopes with higher masses are sometimes radioactive. So a higher mass gives you radioactivity, so it means they give off radiation, and they play an important role in radioactivity and in medicine. Okay, now let's look at a few examples of isotopes. Here you can see we have hydrogen. Hydrogen is actually a triplet. You don't get one type of hydrogen, you get three types. You get normal hydrogen that we have, then you get deuterium and tritium. Tritium. Okay, so they are all hydrogen, 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 but their mass differs. Okay, so we retabile. For the first one there, how many protons does it have? One. And how many neutrons? Zero. Because 1 minus 1 gives you 0. See, for the next one, how many protons? Say again? No? 1. And how many neutrons? No? You can call Rita Billy to ask you. How did you get to 1, Rita? So she said the mass minus the atomic number. 2 minus 1 gives you the number of neutrons. Remember, neutrons is the mass minus the number of protons. Okay, so that is 2 minus 1 gives you 1. Nekano, how many protons for tritium? And how many neutrons? How did you get to 2? More. Okay, so there on the side, I'll show you what they look like. So here is the normal hydrogen with 1 electron spinning around him and 1 proton. Here you have deuterium, you have the proton, and the neutron, and then the electron. And here you have tritium with 1 proton, 1 electron, and then 2 neutrons. Yes? Not yet. We're going to work with H plus a lot, and that's the same as saying we have a proton, and that's where they got that from. But not yet. Okay, then next one, carbon. We have also 3 isotopes from. So carbon is also a triplet in nature, actually. So we have carbon 12, carbon 13, carbon 14. That's its names, actually. Carbon 12, carbon 13, 14. Rory-san. For the first one, how many protons? How many neutrons? How did you get to that? Okay, good. Bukamuso, next one, how many protons? And how many neutrons? Nope. How did you get to 7? Alright, last one, how many protons, Hope? And how many neutrons? 8. How did you get to that? Yes. Gives us 8. Alright, next one, chlorine is a twin in nature. There's two chlorines. The first one, how many protons, chlorine?
70.
And how many neutrons?
80.
Good. And then chlorine 37. Oh, there I missed something. That must be chlorine 35. Chlorine 37, Kamu?
17 protons.
And
20.
wait. Okay. Right, now I'm going to stop there for today. I want to show you a video actually. Okay, so while I show the video and get the video, your homework, your homework will be on page 13. On page 13. Okay, I want you to do the following. This table, this whole table. Okay, but you can leave out for now, don't scratch it out, we're going to do it later. You can leave out this one, and this one, and this one, and this one, and that one. You can leave out. Okay, the rest you can do this on the table. Yes?
And can you turn carbon into water?
Into carbon dioxide into water? No.
Oxygen.
Can react with something to give you water, yes.
With what?
Hydrogen. Okay, then I want you to do not do there. I want you to do number 3. And number 4. Okay, that will be your homework. And then I'm going to show you a video in a moment.